Good morning, guys. Hopefully you're doing all right. I just had a peek and it looks like you guys weren't doing any English this morning, so all math all the time. It's great. If you can give me a green check in chat and let me know if you're there, you can hear me, you're doing okay, we'll get going. Perfect. Well, you had planning. Oh, you had planning all morning? I didn't know that. I just looked at my schedule and I saw there's no English. Maybe it was all planning this morning. If you had any questions from the learning guide from Unit 3, the stuff that we did last day, if you want to put those in the chat, I'd be happy to look at those. If not, I'll just move on to the next assignment and we'll just kind of plug through that. I'm hoping there isn't a ton of questions from the last section because it was a lot of stuff that you've probably seen before. So hopefully you get a chance to look at it. Negative powers number 3, for sure, I can have a look at that. The course kind of, gets mixed up here between these units because you guys are trying to finish off Unit 1 and then I'm moving on to Unit 3. So it's kind of why it's important to, stay as current as possible and ask questions as we go, and we can definitely address some of these issues as we go. I've gotten like 3 or 4 learning guides for Unit 1, and I think I've given them all back and sent out passwords for that stuff. Some of you that had been a little bit behind doing the Unit 2 stuff still, getting that stuff done, which is great. Moving forward is really important, and I understand you guys are working hard at that, so I appreciate it, all the work you guys are putting in. So it looks like we have a few questions off the learning guide here. I'll go do negative powers, multiplying, dividing powers, 5a and b. Savannah's on her learning guide for Unit 1. Perfect. I guess in terms of the course, I'd asked if you could get your learning guide in for yesterday or today. I just want you guys to have time over the weekend to finish the Unit 1 test off. Again, there's not as much material for the Unit 1, so it should be a little bit more straightforward. At least I think it is. So if you can get that in by the end of the day today, I will have you the code for the weekend, and you can just pick whatever time works best for you, either Friday, Saturday, Sunday, to get that Unit 1 test out of the way. So that's kind of my hope. There's still a few people who haven't given green checks. I assume you just maybe signed in a bit late, or you were kind of running around and just didn't hear me ask for them. Belle and Ava are now in, which is good. Maybe you started a little bit early. Looks like everyone's there now. Lots of green checks. Perfect. For those of you who just signed in, I guess Ava and Belle, if you had any questions from the learning guide, from the first section there that you wanted me to go through, I'm going to go through those. There's a few that have been asked already, and yeah, I'm just going to jump in there for that. So, Unit 3 learning guide questions were negative powers number 3. We didn't get to negative powers yet. Oh, yes, we did. All right, so negative powers number 3, should get to that. Multiplying, dividing radicals 1n. Multiplying powers. Dividing powers. Am I missing the section here? Multiplying, dividing radicals 1n. Oh, that's from the last section. Alex, is that right? Yeah, perfect. I'll try to get to that at the end of the class. I just want to kind of I don't want to jump around too much because people start getting confused. So remind me at the end if I still have time. I'll definitely do that, Alex. Dividing powers, 5a and b. Multiplying, dividing powers, 5. This was the one I warned you about with the negative sign. And C. What else? Dividing powers 5 in B, in guide. Questions unit 1. Dividing powers 5C, multiplying powers 4BC. Dividing powers 5C. Let's see if we can find that. So all of question 5, I guess that's tricky. Multiplying powers 4B and C. Should be up here. 4B, C. Multiplying powers 3D. All right. Is that right? All right. I think that hopefully Haley meant C. 1C, 1C. Multiplying, dividing powers 1C, not 5C. Dividing powers 1C. Okay. That guy. All right. I'll just start up here at number 3, and then if you guys, oh, there's another one. Multiplying powers 4. 2, 3, 4. Okay, there's a couple out of 4 already there, Alex. So if I don't go through one that you needed, then we'll see. And you can throw it in again. So the first one here was the negative powers. If the power does not have a bracket around the negative, the answer will always be negative or positive. So if you remember from last day, we did this question. Where did it go? With the power of 0. We had the 2 examples with right here, these guys. We had the negative outside the brackets and then the negative inside the brackets. That's the same question as what we're looking at right here. So it's just asking in general, if the power does not have brackets around the negative, the answer will always be I'm not sure I'm understanding this fully. If the power does not have brackets around the negative, the answer will always be, I'm thinking negative. So if we had something like negative 2 to the power of 4, this is the same thing, and this is kind of what's written up above here. The same thing as negative 1 times 2 to the power of 4. 2 to the 4, 8, 16. So you'd have negative 1 times 16. Should be negative 1? Yeah. So that's kind of the idea here. Anytime we have an exponent and then you have brackets, there's a negative number in front. It's the same thing as negative 1 times that thing. So that's kind of why it works out that way. If the negative sign is within the brackets, yeah, and Alex, that's a good point. That's what I did mention in class, what I did say. So I guess it's just going to depend on the circumstances. Generally speaking, what you've written there, Alex, is correct. So we're going to go with that. That'll be good. The reason these questions are here is because you get these finicky little ones, like the one I showed you in class, and like the ones I'm going to do here in a second, where you end up with the power being, I'll just wait till I get to them. You end up with the brackets on the outside and the negative on the inside, and just kind of gets all confusing. So I know it's kind of weird. The learning guide and the course online here always writes these things like this. So you have negative 3 to the power of 4. They're breaking it down as negative 1 and negative 3. And then negative 1 times 6 to the power of 7. So that's how, I guess, things are being dealt with within the learning guide. So it said it's always negative. So, okay, so that's the way this is doing it. I wouldn't necessarily agree with that, but in terms of being consistent, I'll just continue on with that. I know I said something different in class, and yeah, I apologize for that. Now I guess that the learning guide's doing it differently. So they're saying, like I just written here, anytime you have a negative outside of the bracket, we're going to have like a -1 times that thing, and it's always going to end up being negative. And that's what this question's asking. So let's look at some more examples here. You probably just had sign errors on some of these questions, I'd imagine. What was the next one that came up? Multiplying powers, 3D here. Taylor's asking about videos for the learning guide. Yeah, there's videos, but none of them have to do with the learning guide. So each lesson has that kind of tutorial built right into the course with some additional practice problems. And then it explains how to get solutions for all those practice problems. So nothing for the learning guide. That's why we get you to do the learning guide and submit it to kind of show that you know what's going on and understand. But there's no videos that go along with the learning guide. Just whatever you guys ask in class, I guess. So because I have the same base, I'm going to add my exponents. So I have s to the a plus b, and then I'm going to add another b. So I have s, and I combine like terms. In this case, I have 2 b's, s to the a plus 2b. So that was that guy. Making sure I have same bases, just add the exponents, combine like terms sort of thing. For B and C, same idea. I'm multiplying, so I'm going to add my exponents together. In this case, my bases are the same, so I can add them together. So I'm just going to write it as one sort of statement here, 4m plus n, and then I'm going to add to that 2m. Now, it's kind of like a grade 9 combining like terms problem. How many m's do I have? I have 4 to the power of m plus another 2m, so I have 3 m's and then an n. And typically we would write these alphabetically, so L, M, N. So we're going to put the m in front just because it comes first in the alphabet. Let's look at letter C. I can only add exponents with the same bases. So in this case, I'm dealing with 2 bases. I have m's and I have n's. So I can't add my m exponents to my n exponents. So I'm going to do kind of like 2-step sort of thing. I have m to the 2. I get my 2 from here, and then I'm going to add to it 7 from there. And then I have n. I have a 5 and a 3. So 5 plus 3. And I can rewrite that as m to the 9, n to the 8. So I guess the important thing here is to remember I can only add my exponents when I have the same base. If I have different bases, I can't. M and n, they stay separate. They're not the same. I have the feeling there's a couple dividing powers ones. So write as repeated multiplication. So I have x to the 6 divided by x to the 3. So there's 1, 2, 3, 4, 5, 6 over 1, 2, 3. If I'm going to cancel, that one cancels with that one. That one cancels with that one. That one cancels with that one. What am I left with? Well, I have these 3 x's on the top. So I get x to the power of 3. And then number 5 here. So like D, you can't add the 3 and the 2. I'm going to just scroll back up to the D. A, B, C, D. I assume you're talking about this one here, Taylor. The 3 and the 2 are numbers, and when I have numbers in brackets, if I just had something like 3 times 2, you'd say, oh, that's just 6. So because they don't have any exponents to deal with, I can multiply them just like I normally would. Remember, brackets just means multiplication. So I'm going to have 6x to the 3 plus another 3, which equals 6x to the power of 6. Perfect. There we go. All right, so number 4, I kind of warned you guys this was coming, and I tried to include some examples in the lesson. Five. Okay, so Avery's asking a question about the one I'm just on here. So for 5a and b in dividing powers, I'm confused because shouldn't anything to the power of 0 be 1 and then either positive or negative? It just depends on where the brackets are. That was kind of what was being alluded to up above there. So let's look at these and we'll see if we can sort this out a little bit further. Just want to make sure I'm in the right spot. All right, so what this is saying here, this is like 4 times x to the power of 0. I could kind of break it up if I wanted to. So then I can say, okay, x to the power of 0 is just 1. So I have 4 times 1, which is just 4. The second one here is the same thing as negative 4 times x to the power of 0. And this is going to be 4. Anything to the power of 0 is just 1. So I end up with negative 4. For this last one, I have everything inside of the bracket. So it's saying all of that stuff in there is to the power of 0. And because it's all in brackets, it doesn't matter what's in there. There could be hamsters and goldfish and numbers and letters and whatever. If it's to the power of 0, it's just 1. It doesn't matter if it's negative hamster times 22. If it's to the power of 0, it's 1. So the brackets are kind of important in this case. So there's nothing to really even show there. It's just 1 because all of that stuff's in the brackets and it's 1. So I know it's really kind of confusing, and all of the signs with these exponents and things kind of get a little bit confusing. And yeah, I don't know if there's any sort of super way to explain it. They don't come up a lot. So there's nothing we can do. And Abby's asking a question though, even though it's negative for C, yeah, even though it's negative, it's just going to be just going to be 1 because the negative sign is within the brackets, right? Another example, if I had something like negative 1 to the power of 0, that's just going to be 1 because it's to the power of 0. You run into a problem where you had something like negative 1 to the power of 0. Well, that's the same thing as negative 1 times 1 to the power of 0. So that's negative 1 times 1, which is negative 1, which is kind of a really, really weird sort of thing that happens as a result of this power to 0 stuff. So if it doesn't have brackets, then it's going to be negative, or at least that's the way the learning guide is portraying this. You know what? I forgot to look up the 0 to the power of 0 stuff. Why isn't to the power of 0, 0? The idea of the power of 0 is something like this. If I had like, let's just pick a variable like x. If I said x squared divided by x squared, what I can do is subtract my exponents. So I get x to the 2 minus 2, and that is x to the power of 0. Or if I wrote them vertically, x to the 2 over x to the 2, what's x squared divided by x squared? It just gives me 1. Or I can do the same thing with numbers. If I said 2 squared over 2 squared, what's 2 squared? Well, that's 4 divided by 4 is just 1. Or if I went like this, 2 to the 2 minus 2 is 2 to the 0, which just equals 1. So that's where the 1 comes from. If you're ending up with a power of 0, because of our exponent rules, when we divide things, we're subtracting the exponents. So if you ever end up with 0, it's just saying the top and the bottom are exactly the same, so you have nothing left. And then once you get to that point, there's just 1. There's just 1 there. Couple more questions. Yeah, but 0 divided by 0 should equal 0, but we can't divide by 0. That's the kind of the problem we're running into there. In math, it's you can't divide by 0. Doesn't make sense. So if you have 0 divided by 0, you can't do it. That's kind of that indeterminate thing that kind of came up last day when I think it was Abby who looked it up online, came up with that. And then Alex, you're asking, why is it over itself? I'm not sure I'm understanding what you're trying to get at there. Why is it over itself? I mean, if the example ends up being an exponent of 0, that's because it was over itself. I don't know if that makes sense or not. Maybe you can clarify a little bit. Give you a second to type that in. I'm thinking that was it for the sections that we had to do. We're going to look a little bit today at some different sort of exponents. I got it? Okay. Different exponent type questions. We're going to look at some new rules, negative exponents today. So is there anything else that I missed that you want me to go through before I just jump on to the next lesson? Will you ever multiply or divide your exponents or just add and subtract? We're going to actually do that probably on Monday's class. We'll be multiplying exponents. I don't think it comes up in today's lesson. Nope, it does not. So yes, we will be, Taylor. You're just getting ahead of us a little bit, which is okay. All right, so looking at lesson number 2, this is negative exponents and reciprocals. And this is just another sort of exponent law that we're going to bring into the problems we've already been looking at. So let's just look at this. So the reciprocal of 2 over 3. You've likely heard the word reciprocal before, but you just might not remember what it means. So the reciprocal is the same thing you're dealing with, just flipped upside down. So if I have 2 over 3, the reciprocal of 2 over 3 is going to be 3 over 2. Now, reciprocals happen in math a lot because sometimes they help us with our calculations. What if I had something like 4? What would be the reciprocal of just 4? It gets a little tricky, but if you think a little outside the box, you might be able to just sort it out without me telling you. If the reciprocal of 3 or 2 over 3 was 3 over 2, if the reciprocal, you guys, the reciprocal of 4 is going to be 1 over 4. And when I said think outside the box, the reason I said that was I can take this 4, and I know I can write 4 as 4 over 1. It's equivalent. If I put it into my calculator, 4 divided by 1 just gives me 4. So if I want to find the reciprocal of 4 over 1, I'm just going to flip it, and I'm going to end up with 1 over 4. So Abby and Avery, you guys were on it. The definition of a reciprocal is maybe a bit strange, but after you think about it for a second, it makes sense. So we define the reciprocal as being 2 numbers whose product is 1. So that's why we like reciprocals, because if we have a fraction, if we multiply it by its reciprocal, we can end up with just 1. So that's kind of the mathematical reason we use them, or the advantage to dealing with them. So this is kind of one of these exponent laws that we're going to need to remember. So far our exponent laws have looked like if we're multiplying numbers with the same base, we're going to add our exponents. If we're dividing numbers with the same base, we're going to subtract our exponents, and anything to the power of 0 is going to give us 1, generally speaking. This is the next law we're going to add to all of our laws. Powers with a negative exponent. So when x is any non-zero number, so x is just a number, and n is a rational number, meaning it can be a fraction or it can be a whole number, a real number, or sorry, not a real number, a fraction or an integer. X to the power of negative n is the reciprocal of x to the n. That is, x to the negative n is equal to 1 over x to the n. This is all just a bit confusing, a bit overwhelming, but if you can remember this, that's going to be the important bit here. Alex is asking a bit of a side question here. What if we multiply with different bases? That kind of happens all the time. The only catch is we just can't simplify these things. So you don't need to write this down, but if I had like x to the power of 2 and 4 to the power of 6, that is multiplying with different bases. That's just as far as I can go. There's nothing I can do to simplify it. If I had something like x to the 2 times x to the 4, well, now I have the same basis, so I can go and say that's x to the 6. So if something has different bases, I just can't simplify it any further. It's just kind of as far as I can go. But if we have the same base, then we can just add them up. So again, reading the definition, the mathematical sort of definition, is kind of confusing. So maybe just look at a few examples and hopefully this will make a bit more sense. So if I have 7 to the power of negative 2, I never like dealing with negative exponents. I just don't do it. So when I have a negative exponent, what I'm going to do is I'm going to write it as the reciprocal, and that'll get rid of my negative exponent. So anytime we do a question in Math 10, you cannot, unless the question specifically asks for it, you cannot have a number or any negative exponents in your answer. If you have a negative exponent in your answer, it means that you need to simplify it further. So that's just kind of the basis for this sort of stuff. Anytime the learning guide, the quizzes you guys do, the provincial exam, you will never see, well, I shouldn't say you'll never, you should never have a negative exponent in your answer, unless the question is asking something silly like, what's the negative exponent, or what's the reciprocal of this, something like that. So we should always have positive exponents. So let's look here. We have 7 to the power of negative 2. From the kind of yellowish box there behind me, we know that if we ever have a negative exponent, to get it to become a positive exponent, we just need to write it as 1 over that thing. So we're going to take the reciprocal of it. So 7 to the power of negative 2 is going to be 1 over 7 to the power of positive 2. Okay, that's the reciprocal. Now I have a positive exponent. The questions ask me to evaluate. I have 7 to the power of 2, and I can actually do that multiplication. So I can write this as, anytime I have something squared, that's just the thing multiplied by itself. So 1 over 7 times 7, 7 times 7 is going to give me 49. So 7 to the power of negative 2 is equal to 1 over 49. Same thing. This is where our calculators are going to kind of let us down a little bit. So on your calculators, you can enter negative exponents. There's nothing wrong. Your calculator can handle that. But the answer isn't going to be 1 over 49. The answer is going to be 1 divided by 49, which is just going to be a decimal. And that's where using your calculator isn't really going to carry you very far in this section, because the answers will all be kind of whole number, sort of integer answers, like 1 over 49. The 49 is an integer, not the decimal approximation for that. That's kind of where we run into problems in this section. The next one is 10 over 3 to the power of negative 3. So Alex saying, then you can exit by 49 and put 1 over that though. Okay. You mean to get from like the fraction, or sort of decimal back to the fraction? Is that maybe what you're getting at there? Again, I'm not sure if I'm understanding that correctly. You can always convert from the decimal back to a fraction. Some calculators will actually give you your answer in a fraction form. It just depends on the calculator and how smart it is. Some calculators have a button that you can just press and it'll convert your decimal to a fraction. So Usually it's like an A/B button. We'll convert the decimal to a fraction. But generally speaking, the questions we're going to be dealing with are going to deal with numbers that are small enough that we can just, we don't need decimals. We can just write them out as they kind of appear. So here we go. This one is 10 over 3 to the power of -3. And anytime I have a negative exponent, I want to get rid of my negative exponent. And I know if I take the reciprocal, I can make my negative exponent positive. So I'm going to take the reciprocal of 10 over 3, which is going to give me 3 over 10. And now my exponent is going to be positive 3. Now you're probably thinking, but in the last question, Mr. Borden, you wrote the power on the bottom with the 7. Why aren't you writing the power on the bottom with the 10 this time? Why is it staying up at the top? I guess what I did for the first question here is I could write it out this way as well. This is 7 over 1 to the power of -2, which is the same thing as 1 over 7 to the power of +2. And then when I put my exponent inside the brackets here, I have 1 squared on the top and I have 7 squared on the bottom. 1 squared is just 1 and 7 squared is 49. So technically speaking, I guess I skipped a couple steps there. Just didn't want to confuse you with this next one. So anytime I have something inside the brackets and I have an exponent on the outside, everything inside the brackets gets that exponent. So what is this going to look like? We could write this as 3 to the power of 3 over 10 to the power of 3. Or I could just write it as 3 over 10 times 3 over 10 times 3 over 10, which is both the same thing. And both get me to the same place. 3 cubed is going to be 27. 10 cubed is going to be 1,000. So I have 27 over 1,000. Can't simplify that any further, so I'm done. All right. The next example is maybe a bit tricky. I generally don't like dealing with decimals. We want to try to keep these questions as whole numbers. So can I represent 1.5 or -1.5? Can I represent it as a fraction? What is 1.5 as a fraction? What do I have to divide to end up with 1.5? If I want -1.5, I can write it as 3 over 2. Now I have this negative sign. It doesn't matter if you put the negative sign on the top or the bottom. How did you get, I took 3 cubed, Taylor, and I took 10 cubed. So 3 times 3 times 3 is going to be 27. 10 times 10 times 10 is going to be 1,000. Or you can look at it in the blue up here. 3 times 3 times 3, 27, and 1,000. All right, so I can put the negative on the top with the 3. I can put the negative on the bottom with the 2. It doesn't matter where it goes. I will always, almost always, put it on the top. Just kind of the way I do these questions. So in order to get rid of my negative exponent, I need to take the reciprocal. So I'm going to flip it. You can leave the negative with the 3 if you want, or you can leave it on the top. I like to leave it on the top, always. I always like my negative fractions to have the negative sign on the top. If you wanted to put it on the bottom with the 3 and get rid of it on the top with the 2, because it was with the 3 before, that's fine. You're not going to get the question wrong. I just like to have it on the top. So I'm going to leave it on the top. Now I have these things to the 4th power. So I'm going to have negative 2 to the 4th power, and I'm going to have 3 to the 4th power. Now, negative 2 times negative 2 times negative 2 times negative 2 is going to give me 16. And 3 to the 4th is going to give me 81. And I'm happy with 16 over 81. Try to simplify that any further. I don't think I can. Nothing goes into both 16 and 81. So there we go. So we can apply the meaning of rational exponents and negative exponents to evaluate powers with negative rational exponents. There's a lot of words in there, negative, rational, all this stuff. Kind of confusing. What it's really saying is if we have exponents as fractions, we can deal with that. So this is going to be kind of like our fourth exponent law that we need to just remember how to use. So the rational exponent with the power of 8 to the negative 2 over 3 indicates these things. The negative sign out front means the reciprocal. If I have something on the top, like a 2, that means I'm going to square it. And whatever's on the bottom is going to be a root. This is kind of the point when this unit gets hard. Not necessarily hard, but just kind of a little tricky. So let's look at a couple examples, and I think after you see a few examples, you'll kind of understand, hopefully, where it's coming from. So the first one here is 16 to the power of negative 5 over 4. Now, in order to get rid of my negative exponent, don't worry about the fact that the exponent's a fraction right now. If I want to get rid of the negative sign in front of my exponent, I take the reciprocal of the thing the exponent was acting on. So it was just a 16, which is the same thing as 16 over 1. I'm going to take the reciprocal of that, and I'm going to get 1 over 16 to the power of 5 over 4. So all I've done is just taken the reciprocal. Now, this is the most common spot students will make mistakes, right here. And the common mistake that students make is, instead of taking the reciprocal of the base, the thing in the bottom, the 16 here, students take the reciprocal of the exponent, which is not correct. So that is the most common mistake students make in this entire unit. When you see your negative exponent, students will try to flip the exponent, which isn't correct. We want to always flip the base. So if the base is a fraction, we take the reciprocal, we flip it. Or if the base is just a number like 16, which is 16 over 1, we flip it and get 1 over 16. Now, following our rule a little bit further, I know that anything on the top is going to be my exponent, and anything on the bottom is going to be my root. So all of a sudden, this 1 over 16 turns into, the 4 is going to be my root, so I'm going to have the 4th root. And then I'm going to have all of this to the 5th power. I know that's a bit of a stretch. It's a good question, Abby. For the question, can we change 5 over 4 into 1.25? We're always going to leave our exponents as fractions because, as you're going to see here in a second, we can use the fractional exponent. It means something. So I'm just going to continue this on a little bit. What is the 4th root of 16? If I have just a 1 on the top, I can just, the 4th root of 1 is just 1. So I can write it like this as well, just ignoring the fact that the top has that. The 4th root of 16 to the 5th power. So the 4th root of 16 is going to be just 2, because 2 times 2 times 2 times 2 gives me 16. And then it's to the 5th power. So 2 times 2 times 2 times 2 times 2, 5 times, it's going to give me 1 over 32. I'm not loving starting with that, because you guys haven't seen fractional exponents before, have you? Has anyone seen a fractional exponent before, like like 5 to the power of 1/2 or something like that? Do you want to give me like a green check mark if you've seen fractional exponents before? Savannah's never seen them. Taylor's never seen them. Okay, let's take a step back then. Maybe in this little margin here above examples evaluating powers, negatives, let's do something like this. Let's go 16 to the power of 1/2. Now, from up above here, I know when I have a fractional exponent, regardless of whether it's positive or negative, whatever's on the bottom is going to be my root. So 16 to the power of 1/2 is going to be the same thing as the square root of 16 to the power of 1. But I don't generally write in my power of 1. And I also generally don't write in the fact that I put a 2 out front here, because that's not something we normally write. So that's kind of one way to write it, or this is just the exact same thing as the square root of 16, which is the exact same thing as 4. Let's do another example here. If I had 27 to the power of 1/3. Whatever's on the bottom of my fractional exponent becomes my root. So in this case, my little 3 here is going to end up in front of my root sign here. So what is the cube root of 27? I'm hoping that's 3. It's one of my perfect cubes. Kind of works out nice. So in your calculator, maybe try this one out here. Try 27 to the power of 1/3 in your calculator. We all found our exponent button last day. So you're going to type in 27. You're going to put in either the hat or the x to the y or the y to the x. And then you might be able to go 1 and then divided by 3 in your calculator, or you might have to put a bracket in first, and then close the bracket, and then hit the equal sign. Just depends on your calculator. So I want everyone to try to put that exponent of 1/3 in your calculator with the 27. Taylor got it. Perfect. Maybe a few more people want to just write in if they're finding some success with that. You got 3? Good. Ami's got it. Again, this is kind of the battle of the calculator. Everyone's calculator is going to be different, and you just want to make sure that it's working out for you. If it's not working out for you, let me know. We can figure it out together. Every calculator is going to be just slightly different. Once you figure it out the first time, you can just, go with that. Or the thing that 1A is confusing. Yeah, I totally get you, Taylor. The examples I included were definitely, I think I might have even skipped a few examples that I normally include. I'm not sure why they're gone, but they're gone. That's fine. We'll go through it together, nice and slow. So, using your calculator Alex's did not work. I'm not sure what was going on with that answer, Alex. It sounds like you might be pressing like the EXP button or something instead of the hat or the Y to the X or X to the Y. Most buttons or calculators have an exponent button, but that's not the button we want to use. So let's look at another example here. let's look at the same example, the 27. But we're going to go 27 to the power of 2 over 3. And what's that going to be? So I know from the example I just did, 27 to the power of 1 over 3, whatever's on the bottom is going to go in front of my radical sign. So I'm going to end up with a little 3 in front there. The base stays as 27, and whatever's on the top is just going to square whatever's there. So I'm going to do this in 2 steps. The cube root of 27 is 3. I know that because I just did it. And then I can write 3 squared is 9. Now Alex is checking something in the history. History says I did 27 y root 1, 3. I'm not sure if that... I'm not sure what the y means there, Alex. Like, what is that y button looking like in your calculator? You should have either an x to the y button, or a y to the x button, or a hat. Do you have one of those 3? Any of those buttons? Those are the ones we're hoping to use. X to the y. It might be how you're entering it, so your calculator might not like the exponent being divided. It might be going, because calculators are kind of dumb. If you go 27 x to the y 1 divided by 3 equals what it's probably, well, it's not what it's doing, but what it might be doing is going 27 x to the y 1, I got you to there, and then it says, okay, 27 to the power of 1 is 27, and then you're dividing it by 3, and that's going to be 9, which isn't what we wanted. So I don't know what's going on there. Maybe just try a few more basic ones. It's always a good strategy for these types of questions. If you just put in really basic ones you know the answer to just kind of try to figure out if your calculator is working like you expect it to, then you can do the more complex ones later. So Taylor's asking why I put it in brackets. I didn't have to if I don't want to. I can just leave the 2-0 back there like that. That's fine as well. There's nothing wrong with writing it this way as well. I just kind of like the brackets because I like to remember that everything inside of the brackets is getting this exponent of 2. I want to do just one more basic one, maybe in the margin here again, and then we'll move on to some of these challenging ones that are in the examples section here. Let's think of a good question. It's going to be a big number. That's okay. Let's go with 36 to the power of 3 over 2. Kind of what we just did, but a little bit different. Kind of 2 ways to do it. You can plug it into your calculator, 36 to the power of 3 over 2, and see what you get. Or